So let me show you a couple interesting consequences of PV equals nRT. Let's start with the concept of standard temperature and pressure, which for samples of gas, standard temperature is 0 Celsius or 273, let's call it 273.15. Okay, that's not. That's only going to make a difference past 3 sig figs, but it might. And then pressure 1 atmosphere. So 0 Celsius, 1 atmosphere, that's standard temperature and pressure. What we can do is solve PV equals nRT for V. Okay? If I've got a standard pressure, a standard temperature, and 1 mole there, we can do P, V, N, R, T. Okay? So standard pressure, 1 atmosphere. We're solving for volume in liters. N, I told you to just try 1 mole. R is a constant, 0.08206. Liters, atmospheres, moles, Kelvin. Temperature, 273.15 Kelvin. Okay, so if we solve this for V, we said if. This is a hypothetical. Okay? So nRT P. So 1 mole, 0.08206 liters, atmospheres, moles, Kelvin, 273.15 Kelvin. P, in this case, 1 atmosphere. So the question we're asking is what volume will 1 mole of gas take up under these standard conditions? 1 atmosphere is a very commonly, it's a very common condition, right? That would be imagining a balloon that's in equilibrium with one atmosphere of its surroundings. Okay? So if we had a balloon that had 1 mole of gas in it, it was equilibrated to 1 atmosphere. Temperature was a little chilly, 0 C, but certainly imaginable. Okay. Did anybody get an answer? Yeah, it's really just R times T, right? 22.4 liters. Okay. That is called standard molar volume. In other words, the volume is 22.4 liters for 1.00 mole of any gas at standard temperature and pressure. You used that calculation, whether you remember it or not, back in the limiting reactants lab. We just kind of told you that conversion when we had to calculate the volume of hydrogen gas that you should be producing. Okay? But it's a very reasonable estimate, okay, for the volume that any gas will take up at standard temperature and pressure. So here's a mole of helium, a mole of xenon, a mole of methane, okay, at standard temperature and pressure. 22.4 liters, it's a large balloon, okay, but it's I mean, definitely doable for a balloon, okay, like that. So think about that. Have that picture in your head. 1 mole of any gas. It's helpful, especially when you're judging if your answer is reasonable or not. It's helpful for you to have a picture in your head of what 1 mole of gas looks like. Okay? So at standard temperature and pressure, 1 mole of gas is a big balloon. Okay? Any gas. 1 mole of solid depends on that solid's molar mass, right? From my other class, there's a mole of copper, okay, 63.5 grams. A mole of carbon is 12 grams, just a tiny little pile. Okay? But really 1 mole of any gas, because those molecules are spread out much further apart than the molecules are in any solid. Okay? 1 mole of about any gas is 22.4 liters. So